Thank you very much, sir, for the introduction. So I'll be covering the various aspects of safety programs, which should be how to implement them. This will be the overview of my presentation. The objectives of safety programs, what are the safety standards which are available, what are the implementation strategies, what are the challenges, and how, what are the future directions and innovations. So as we know that I think this part has been covered very well. So the video on the right side of the screen is just 5 milliwatt laser with continuous exposure. How are the effects? And the video on the left side is 5 milliwatt laser. And you can see the effects of a 5 milliwatt laser that it can cause burning, it can cause cutting. And if we go to the military use of these lasers, then it goes to even 100 to 1000 times of this power, which can subsequently lead to extensive damages, be it the drones, be it the aircraft carriers, and be it the satellites. So lasers are highly focused, pointed beams with very high energy, very accurate. So that is why they are finding the military use nowadays in excess. And a lot of research is going on in every country to develop the laser-based military weapons. Now, this part has been covered earlier to some extent. First of all, we have to know what are the various classes of the lasers are present. So, as has been covered, that class 1 lasers are, which are very safe under normal use for everyone, even if you are viewing them with optical instruments. Then class 1M are the ones which are normal viewing condition, they are safe. But when viewing with the optical instruments, they become very, they can be hazardous. Class 2 lasers are all visible lasers. All visible lasers, the advantage of visible lasers is that they can induce a blink reflex, and that can cause the, that can give a safety, safety factor. So class 2 and class 2M. Class 2 lasers, less than 1 milliwatt. And class 2M laser, which are safe under the normal viewing but can be hazardous if some optical aids are used. Then class 3 lasers, again 3R and 3B. 3R is 1 to 5 milliwatt and 3B is 5 to 500 milliwatt. And class 4 lasers are very high power lasers, more than 500 milliwatt. So when we started preparing for this topic, it was actually thanks to General Parihar sir that we could see our lasers, and we just try to find out what are the various insignias or what are the various labeling of our lasers that is there. So we went through the YAG lasers, 1064 nanometers, what are the various signs or danger signs or what is written on them. And I'll come to that because that's very, very important part of the safety or a prevention program. So this is a frequency doubled ND-YAG. So that is where the importance of safety programs comes into being. To prevent the accidents, fostering a safety culture, and setting the clear goals and regulatory compliance. Very, very important. So which are the standards which guide all the laser machines or equipments which are presently available in our country? So these are the BIS standards of IS16071 of 2013. Now these standards are aligned actually with IEC standards of 60825 of 1. Now aligning provides these actually a global safety benchmarks. Now what do these standards and how do these standards evaluate the various machines? Every machine hazard analysis has to be done and the risk assessment has to be done. Hazard analysis is done by two factors, that is accessible emission limit and nominal ocular hazard distance, and also the risk evaluation. So there are some engineering controls and safety features which have been specified for these machines. Now what are those engineering controls? That every laser machine should have a protective housing. That protective housing is very important to prevent the laser radiations from exposing the individuals around. Then second is every laser should have a laser switch on and off key. So if you see all the laser machines which are available with us, they have a key available in that with which you can switch on and switch off your laser machines. Third is the beam stop and attenuator. So this is an inbuilt mechanism which decreases the exposure or that blocks the laser emission in case of required. and then there is an emergency shut-off switch. Now this is also available on every laser machine or equipment which is available anywhere, be it medical laser or industrial lasers. So these engineering controls and safety features are must. So all of you should see actually with your machines whether these compliant features are available or not. So laser, especially the laser switch on and off key, as well as the emergency shut-off switch. Then the next part of these standards comes the administrative controls and operational requirements. So administrative controls, so every laser machine should have a laser safety officer nominated for that. There has to be SOPs. The access control has to be into the laser machines which are located. There has to be training and education, and also any incident, if it happens, that has to be reported. Then these warning labels and signages, again they are available on every laser machine. The first one, that is a starburst pattern. So that is the basically label for any laser machine that is available on all types of laser machines. Then depending upon which class the laser is, whether it's a class 3B or 4, then a danger sign is put, and if class 2 and 2M, then a caution sign has to be put on that laser. And also the classification labels have to be there. Then there have to be beam enclosures. The access to the laser room has to be controlled. So it should be the controlled areas. The ventilation and exhaust system have to be proper, and electrical safety has to be ensured in the laser areas. Now let's see our lasers which are available. I think all of you have got this Nd:YAG laser. So now the most, I think one of the major mistake that everyone does is that they start using this Nd:YAG laser as a slit lamp. By using the Nd:YAG laser as a slit lamp, because it has got a good lighting, so it's kept in a OPD. So once it is kept in the OPD, the first and foremost thing of access control to that room, that thing is compromised. So it's not recommended that you start using the Nd:YAG laser as a slit lamp, because then the access control, then you are violating all the regulations which are available. Secondly, as Parihar sir has told, that there was a case of cataract that happened following exposure to the Nd:YAG laser. So that happened because those regulations have been violated to some extent, which have to be adhered to. So that can happen. So that is why using a Nd:YAG laser as a slit lamp in a no access control area, that is in OPD, is not recommended. So it should not be done. So that access control areas have to be there wherever the laser machines are kept. And also all these labels have to be ensured and seen that which class of laser it is. Does it have that access key? Does it have that on and off key? Does it have the emergency stop which is working or not? Once this all is ensured, then it's safe to use these lasers, and all these regulations have to be adhered to. So I think with this I conclude. Thank you very much.